All right, we're going to talk about triangle inequalities. All right, first thing we're going to do is we're going to talk about side lengths and angle measures and how to determine which is our shortest, medium size, and longest side. So let's take a look at this theorem, Theorem 510. All right, it says if two sides of a triangle are not congruent, meaning they're not equal to each other, then we can conclude that the larger angle lies opposite the longer side. Okay, so if we look at this diagram, we're going to be talking about angle Y. Okay, it's outlined in red. And we're going to be talking about line XZ. All right, we're also going to be talking about line XY and then angle Z, this little blue guy down here, just to highlight what we're looking at. So it tells us, if I tell you that side XZ is bigger than side XY, okay, so the red is, oops, sorry, wrong color. The red is bigger than the blue. Okay, that side is bigger than that side. Then from there, we can conclude, well, the angle opposite XZ, so angle Y, is also going to be bigger than angle Z down here. Okay, so the longer side lies across from the longest leg, smallest and smallest, vice versa. All right, so we can also say that if two sides of a triangle are not congruent, then the opposite is true. The longer side is across from the largest angle. Okay. So what does this all mean? Let's take a look at it down here. Okay, so which choice shows the sides of triangle TUV in order from shortest to longest? So once again, we're going to use the angle measures to order the sides, and we can do it vice versa. We can use the side lengths to order the angles. So taking a look at this, I have two angle measures. I need to find the third. So remembering what we know about angles, I'm going to add up my 58 plus 62, and that equals 120. And then to find the third angle, I can subtract that from 180. So this third angle up here is 60. Okay, so I'm going to use those to help me order the sides. So it's asking me to go shortest to longest, so I'm going to find the shortest first. The shortest side is across from the smallest angle. So looking at my angle measures, 58, 60, 62. 58 is the smallest angle. So this angle is across from, it makes up the other side. So if I were to trace that angle, the side that's not colored in is the side opposite it. So that means that TV is going to be the shortest. All right, next, I'm going to look at the next one. 60 is the next biggest angle. Okay, here's my 60-degree angle. It's from here to here. So the side that's across from it is down here. It's UV, so that's the next biggest side. And then lastly, the biggest angle is right here, 62 degrees. It is angle length V. So the side across from that is side UT. So I'm going to match that to the choice, and it's going to be choice A. All right, pause the video, go ahead on your own. Order the sides from shortest to longest. Actually, it just says which one is the shortest, so find the shortest side. Pause the video with me. All right, and side OX is the shortest because when I found my angle measures, even though I can't see them, I just filled in what was given to me, 130 and 24. So to find the last one, I added up 130 and 24, subtracted it from 180, and I got 26. So that means this guy's 26. And then I figured out, well, if the shortest side's across from the shortest angle, therefore it is over here, it's side OX. All right, moving on. Okay, now let's talk about sides in relation to a triangle. The directions say for three segments to form a triangle, their lengths must be related in a certain way. Okay, not just any three sides can form a triangle. Notice that only one of the sets of segments below can form a triangle. The sum of the smallest two lengths must be greater than the greatest length. Okay, the sum of the smaller two lengths must be greater than the greatest length. So take a look at this drawing. On the left, you actually have a triangle. And what it's saying is to you, the sum of the smallest two lengths, 3 and 3, has to be greater than 5. So 3 plus 3 is 6. Is 6 greater than 5? Yes, it is. Okay, so that's why it makes a triangle, because think about it. They're big enough where they kind of bump up. They don't meet completely. It's not a straight cross line here. Versus if you look over here, 2 plus 2 is 4. Is 4 greater than 6? No, it's not. These two, if I bring them down here, okay, if I swing them down, you know, the 2 only measure to about there. If I swing this down, only to measure there. They don't meet up. They don't match. It's not big enough to make an actual triangle. Okay. The directions say, for a neighborhood improvement project, you volunteered to help build a new sandbox at the town playground. You have 2 boards that will make up 2 sides of the triangular sandbox. One is 5 feet long and the other is 8 feet long. Boards come in the length shown. Which boards can you use for the third side of the sandbox? Explain. Okay, well, using what we talked about before, the sum of the 2 sides has to be bigger than the third side. So let's go ahead and let's do 8 plus 5. That is equal to 13. So those 2 together have to be bigger than the third side of the triangle. All right, so I know that 15 cannot work. It is a no-go. All right, 12 could work because it's less, etc. Now I also want to take a look down here, okay, because if I were to plug 2 in, so I'm going to use a trial and error method. If I plug in 2, so let's say my 3 sides are 8, 5, and 2. 8 plus 5 is 13, which is bigger than 2. No big deal. But if I do 2 plus 5, that equals 7. Is 7 greater than 8? No, it's not. Okay, so what that's telling me is my 2 smaller sides are not bigger than the biggest side if I were to use 2. So therefore, that option cannot work. All right, I can check the others. 5, 5, 5, and 8. 2 smaller sides are 5 and 5. 5 plus 5 is 10. Is 10 greater than 8? Yes. Okay, so that can work. 8, 5, 8, and 8. 2 smallest sides would be 5 and 8, one of the 8s. 5 plus 8 is 13. 13 is greater than 8. It works. All right, and then 12, 5, 12, and 8. 5 plus 8 is 13. 13 is greater than 12. Okay, so these 3 work. The other 2 do not. All right, so let's tie this all together. What exactly was I talking about? Well, our triangle inequality theorem states that the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. Okay, and you can check this, excuse me, mainly by looking at your 2 shortest ones having to be bigger than the third, but it's always good to check every possible combination. So looking at this, I have xy, which is in red, I have xz in purple, and yz in blue. So what we're saying is if you were to add 2 of the sides, so let's take a look first, xy plus yz. xy plus yz, when I add the values together, have to be bigger than the third side, which is xz. That's the only one not named. Also, yz plus zx. So yz, zx is down here, have to be bigger than the third one, which in this case is our yx. And then lastly, zx and xy have to be bigger than the third one, which is yz. Okay, so we're going to apply that, but just keep that in mind. Any 2 sides have to be greater than the third side, the sum of any 2 sides. Okay, so we're going to use that to help us answer this question. Can a triangle have sides with the given lengths? So if I give you 3 numbers, will they make a triangle? Okay, so I'm not just saying draw a triangle. I'm saying if you're given these 3 specific lengths, do they add up? So we're going to use what we just talked about. We're going to check every combination. So I'm going to add 2 of them together, and it doesn't matter which 2 I start with. The sum of those 2 have to be bigger than the third side. So is 10 greater than 8? Yes. Check every combination. If only one doesn't work, then it's not true. So now I'm going to try 7 and 8. 7 plus 8 is 15. Is 15 greater than the third side, the side I didn't use, the 3? Yes. All right, and lastly, 3 plus 8 is 11. Is 11 greater than 7? Yes. So therefore, since every combination worked, then those 3 sides can form a triangle. Okay, let's take a look at the next example. All right, 5 plus 10 is 15. Is 15 greater than 15? No. Okay, so right away I can tell it's not going to work. Now here's what I want you to be careful of. If I were to do another combination, like 10 and 15, 10 plus 15 is 25. 25 is greater than 5. All right, so some of them may work, but every single combination, so all 3 of them have to work in order to make a triangle. So this one is a no. All right, pause the video, try it on your own. All right, no, they cannot form a triangle. I just figured out right off the bat, 2 plus 6 is 8. That is not greater than 9. It's no-go. All right, last concept we're talking about today. So you can determine now if 3 sides form a triangle. Now let's be given 2 and we need to find the range. So algebra says, in the solve it, you explore the possible dimensions of a triangle or sandbox. 2 of the sides are 5 and 8 feet long. Now we need to find the range of possible lengths for the third side. Because if you remember back to the other problem, we had multiple possible solutions. We said 12, 8, 5, okay? So really what we can do is we can find a range of numbers that will work. So I'm going to show you how. All right, so, no, sorry. I'm going to show you how. So to use the 2 sides you have, we need to find what I'm calling the upper boundary. It was 8 and 5. So we're going to add them together. 8 plus 5 is 13. So 13 is the upper boundary because remember, the third side has to be smaller than the sum of the 2. So the third side cannot be 13. Okay, 13 has to be greater than the third side. We'll come back to that in a second. To get the lower boundary, I'm going to subtract the 2 I have. So once again, I'm finding a possible range for all possible lengths of the third side. So I have the range of 3 to 13. We need to write that as an inequality. So that third side cannot be 13. It has to be less than 13 because we already looked at that. If it's equal, it does not work. And it has to be greater than 3. So this would be your answer, this inequality right here. X is greater than 3 and X is less than 13. Keep in mind, it did not say less than or equal to. X cannot be 3 or 13. It has to be bigger than 3 and less than 13. Now it could be 3.1 or it could be 12.9, but it cannot be the exact numbers. It has to be in between them. So I subtracted for the lower boundary, added for the upper boundary. All right, go ahead, pause the video, try it on your own. All right, take a look. Notice I'm doing bigger number minus smaller number. Do not get a negative. That's wrong. So my range is 3 to x to 11. X is greater than 3 and less than 11. All right, last thing, finish up with a check. I'm going to pause the video. I'm going to go through and I'm going to do these, and then I'll play them and you can check your answers. Bring your questions to class though, okay? I'm not going to go through and explain them all right now. All right, please pause the video and do this lesson check on your own. See if you understand. All right, take a look at the answers. Please pause the video. I'm going to stop recording, so pause the video so that they don't disappear. Okay, mate.